So yesterday we did everything. Like I said, you guys got a little bit farther than all my other classes. So we're going to just start by going over the homework. Again, they love their graphs on the earth science region, and they love just basic graphs. So you can see we have the angle of insolation on the x-axis and the intensity of insolation on the y. Without really even looking at the graphs too much, in fact, I'm just going to draw my own down here. If we have angle here and intensity here, if we have a low angle, how strong, actually, do you guys know what the word intensity means? If something's really intense, oh, that's not earth science. No, I know you guys know that. Okay, yeah, thanks. Intensity means like how strong it is. So if the sun is really intense, it means it's really strong. So if we have a low angle, how strong is the sun?
Not strong.
Not strong. So that would be
If we have a 90-degree angle, is strong.
Oh, okay. So you got this. Low, 90-degree, really strong. Graph should look something like that, which matches up with answer 3. Graph to the right shows air temperature on a clear summer day from 7 a.m. to noon in 2 locations, one in Florida and one in New York State. Air temperature rose slightly faster in Florida than in New York State because Florida what? Go through each one. Does Florida have a lower angle of insolation? No. Does Florida have a higher angle of insolation? Yeah, why does Florida have a higher angle of insolation? Closer to the equator. The closer to the equator you are, the stronger the angle of insolation. Or the higher the angle, the stronger the intensity. Why do you think they put these two primary in question answers? Yeah, what are they trying to think that you're going to mess up? Equator, yep. So they were going to think you'd answer 3 because it's closer to the prime meridian, but it is truly closer to the equator. So be careful with that. And finally, the average temperature of the North Pole is colder than the average temperature of the equator because the equator 3, yeah, receives more intense insolation. Okay, by the way, why does it receive more intense insolation? Why? Yeah, why? Higher angle. So more intense because of higher angle. And page 16. Once again, they have a horrible, ugly, nasty looking graph. But if you look here, we have years here. Here is, what does that say? Difference from normal temperature. So if 0 is normal, this is 0.2 higher, 0.4 higher, 0.6 higher, 0.2 lower, 0.4 higher. So we want to know what is the most probable reason for the atmospheric temperature decrease shortly after each volcanic eruption. 3? Yeah. Volcanic dust blocked the insolation. So instead of so basically that's talking about the atmosphere transparency. The dust basically acted like sunglasses or blocked the sun from reaching Earth. Which one of these surfaces usually reflects the most? Which one will reflect the most? The most. No. So yes, they both, definitely not dark soil, definitely not green grass. Lake water and snow will both reflect a lot, but snow is going to be that light color and smooth, which will reflect a lot more. That is a tricky one though. All right, this one required a little bit of reading and thinking. The diagram to the right shows a light source that has been heating 2 metal containers of air for 10 minutes. Both cups are made of the same material and are equal distance from the light source. compared to the amount of energy reflected by the shiny cup during the 10 minutes of heating, the amount of energy reflected by the black cup. The black cup will reflect less, more, or the same. It'll reflect less. So that's a case where the wording probably messed you up more than anything. We don't ever think of black and reflecting. We think that black absorbs. So if you had said greater, it absorbs a greater amount, but the question asks what happens or how much is reflected. And then finally, which type of land surface would probably reflect the most during solar radiation? So again, we want reflect the most. One, light and smooth. And the last question, a person in New York State worked outdoors in the sunlight for several hours on a day in July. Which type of clothing should the person have worn to absorb the least? 4, absorb the least means, another way of saying absorb the least would be what? Reflect the most. So light colored and smooth reflects the most. So that's a case, again, they love to mess with your head with the readings on these ones. So just read carefully and make sure you know what they mean. So we're not, like I said, we're just going to try to get page 17 here. I think we can probably get through this. And not be too far away from everybody else. No, you're way ahead of everybody else.
How much?
By like probably half a period, if not more. All right, so we're starting on page 17 where it says terrestrial radiation. Yeah, I do, right? There. Just try to remember to give it back. Did it just jump right out of your hand? Okay. Guys, what's the word terrestrial mean? Yeah. Okay, I get out there with that. Terrestrial, where have you heard that word before? Terrestrial. TV. Yeah, what particular movie might you have? E.T. What's E.T. stand for?
It's the alien.
It is an alien. Do you what? Extraterrestrial. So E.T. was an alien and he was called extraterrestrial.
Because it's special?
Well, he definitely was special. He was, so terrestrial means from Earth. So extraterrestrial means not from Earth. He was an alien. So terrestrial just means from Earth. I think we should start there. So the word terrestrial means Earth. And what does radiation mean? Gives off heat. So terrestrial radiation is the Earth giving off heat. Officially, the definition I want you to add to that is radiation from Earth's surface. So not too much there.
And so that which line?
Just that first one.
Oh, okay. I was gonna say.
And underneath that is the word infrared. When have we heard that word already this chapter? Infrared. Infrared right here is part of the electromagnetic spectrum. Do you remember what infrared waves are? Infrared scopes?
Nope.
Goggles? What do they see? Heat. Okay, so in Call of Duty, when you put an infrared scope on the gun, or in real life, if you're hunting, or in the Army or the Marines, and you put an infrared scope on, what? You can see the heat from the body. So you can't actually put the scope on and like see the perfect, like you can't tell if the person is like smiling at you or you can't even tell if it's the back of their head from the front of their head. You just know that there is heat in the form of a body there. So infrared is heat. So infrared is long wave radiation emitted from Earth's surface and other terrestrial objects. So add that to where it says infrared. Where does the Earth get heat from?
Before.
Not on the surface, no. The sun. So hang on, I'm gonna go back just a second. I'll come back to this in 1 minute. Remember these notes we took yesterday?
Yeah.
So half the energy that comes from the sun gets blocked out by the sun, or blocked out by the clouds, sorry. 8% gets reflected by the Earth's surface, but a little less than half just gets absorbed by the Earth. And it warms the Earth's surface. So then what happens to that heat is terrestrial radiation. So it is the long wave radiation that's emitted from Earth's surface and other terrestrial objects. So once the Earth's surface gets warm, like the blacktop getting warm from the sun, that blacktop just doesn't stay hot forever. What happens to that blacktop? Doesn't just stay hot forever. No, what happens to that blacktop of it? It cools off very quickly. When will the blacktop cool off?
When the sun goes away.
As soon as the sun's going away, whether it goes away because clouds are there or the sun goes away because it's nighttime, the blacktop will then cool down. Where does that heat go then? Up in the air. Perfect. And it goes up in the air in the form of infrared radiation, which are those longer wave radiations that hit Earth. So here again, the numbers don't so much matter as long as you see that just a little bit of that heat gets completely lost out into space. But most of that heat is actually going to get trapped in the atmosphere by gases. So add those two notes to the arrows there. And does anybody know what this is called when heat gets trapped by certain gases? What? This is the greenhouse effect. Ever heard of it?
No.
Never?
Never.
Ever? You must live under a rock. Something like that. Do you guys ever been in a regular greenhouse?
Yes.
Whether you're going shopping for your parents with for plants in the spring, or whether you're over in our actual own greenhouse, or some of you might even work in one.
It's full of different things.
So first of all, it's covered with glass. And it's hot.
Very humid.
And typically very humid. Why is it covered in glass?
So the sun can go through it.
So the sun can go through it. So this is my makeshift greenhouse, and you have this exact same picture in your notes. I made this. Does anybody recognize what these pictures are here?
So
It looks like a broom.
It's one of the index fossils on the bottom of pages 8 and 9. I thought they looked like plants, and I couldn't figure out how to do this better, so I used them instead of actual plants. It works. But anyway, so we have sunlight coming in. And so sunlight coming in to the greenhouse. And as we said yesterday, most of that gets, about 43% gets absorbed by the Earth. And now what we said is it radiates back into space. And as you can see, it looks like what was going out gets trapped. What's another thing that you notice difference between the incoming light and the outgoing heat? First, it doesn't leave, what? Okay, the waves. Notice how much smaller these waves are, the squiggly line. I made those have smaller wavelengths on purpose. That's because what is the most energy? What's the most, how do I want to word this? Which one of these on the electromagnetic spectrum do we receive the most of at Earth's surface? We briefly talked about this. Visible light. We typically get the most out of all of this is the visible light that we get a lot of. Visible light is over on the smaller side of the wavelength chart versus the infrared, which is on the bigger side. So that small wavelength can make it through the glass and heat up the Earth's surface. But when those bigger wavelengths try to leave, they get stuck inside the glass. And that's exactly how it works in the actual atmosphere as well. The little wavelengths can make it in, but as the big wavelengths try to escape, they get stuck. I have a video that explains this much better. It's gonna take me a second to find it. Give me 1 second though. Oh shoot. Only like I've watched it 800 times. I think this is the one. Logan, you wanna grab these microphones? Do you mind?
Global warming, or
This is not-
none like it hot.
Oh, it's cool, it's cool. Yeah, please.
You're probably wondering why your ice cream went away. Well, Susie, the culprit isn't foreigners, it's global warming.
Global Wapoo?
Yeah. Meet Mr. Sunbeam. He comes all the way from the sun to visit Earth.
Hello, Earth. Just popping in to brighten your day. La 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 la. And now I'll be on my way.
Not so fast, Sunbeam. We're greenhouse gases. You ain't going nowhere.
Oh! Ah! Oh! Ah! Oh! Oh, God, it hurts!
Pretty soon, Earth is chock full of sunbeams. They're rotting corpses heating our atmosphere.
How do we get rid of the greenhouse gases?
Fortunately, our handsomest politicians came up with a cheap, last-minute way to combat global warming. Ever since 2063, we simply drop a giant ice cube into the ocean every now and then.
Just like Daddy puts in his drink every morning. And then he gets mad.
Of course, since the greenhouse gases are still building up, it takes more and more ice each time. Thus, solving the problem once and for all.
But-
Once and for all!
Was it kind of me?
Yeah.
Oh, on that. Shoot. Where did it go? Okay, so yeah, it's not. All right, I want to just go back. There's lots of jokes that I don't want to really
Your
acknowledge
day.
here.
Your day.
No.
La 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 la
I wanna talk
la.
about
And now I'll be
is
on
the
my
sunbeam
way.
Coming
Not
in.
so
Oh,
fast,
and it's the
Sunbeam.
coming in. So the
Global
sunbeam
Wapoo?
into the
Yeah.
atmosphere, no.
Meet Mr. Sunbeam. He comes all the way from the
They come
sun
in,
to
they
visit
warm up
Earth.
Earth,
Hello,
and then
Earth.
when they
Just
try
popping in
at
to brighten your
nighttime,
day. La la la
they
la
get
la la
blocked.
la.
Who they
And
get
now
blocked
I'll be
by?
on my way.
Not so
Greenhouse
fast,
gases.
Sunbeam. where
So
greenhouse
those
gases,
sunbeams
you
get
ain't
stuck
going
here. Now,
nowhere.
one thing I want to talk about is, so do you think it's a good thing the sunbeams get stuck or a bad thing? Why would it be a good thing? Right. Without the greenhouse effect, it would be too cold for life on Earth. Mars does not have an atmosphere that has any greenhouse gases on it. So when the sun shines on Mars, yeah, it heats up, but then it immediately leaves because there's no gases to keep any of the heat there. How'd what get there? The gases?
Yeah.
Well, that's our atmosphere. So through evolution, like it started with first with like bacteria that didn't need oxygen, that made oxygen.
Why are they making it seem like a bad thing then?
Well, cause hang on. So I think it says that. Okay, so yes, it gets heat up.
God, it hurts!
But what
Pretty
happens
soon,
is
Earth
when
is
they
chock
start
full of
to
sunbeams.
pile up,
They're rotting
when
corpses
more and
heating our
more
atmosphere.
sunbeams get trapped, that's global warming. Why would more sunbeams be getting trapped today versus back in like the 1800s? Cars, factories, pollution. Burning of any fossil fuels releases more greenhouse gases.
They had more fossil fuel back then than they do now.
In the 1800s, they like the beginning of the 1800s, they didn't, and we still do today have quite a few factories that. So maybe if I had said 1700s, it would have been better, but I meant like 1800, not like 1899. But anyway, so all those greenhouse, now there's more of these bullies beating up the sunbeams, causing more sunbeams to be trapped here. So there is a difference between greenhouse effect and global warming. Without greenhouse effect, we couldn't live here. Global warming is basically greenhouse effect on steroids. More and more of those sunbeams getting trapped here on Earth. Now, I was wondering if you guys know what greenhouse gases are. One is carbon dioxide. Methane is another. Perfect. So that's, screen share, this one right here. That's where we're gonna leave off is, if you will, this goes in the greenhouse effect box. It is the 3 bullets, but then we are done. I'm gonna say, how about you do the no homework. My other classes are not gonna get that far, so again, greenhouse effect occurs when those long waves, those infrared waves get trapped in Earth's atmosphere. Greenhouse gases are carbon dioxide. So yes, the air we breathe out is a greenhouse gas. So more people equals more greenhouse gases. But again, carbon dioxide comes anytime you burn something that was once alive. It will release carbon dioxide. So yeah, if you burn a log, you will release carbon dioxide. But burning wood is kind of like, because trees make oxygen and take out carbon dioxide. When you burn wood, it's kind of a neutral. But what happens is, since we started burning fossil fuels, we release trapped carbon that was no longer really in our atmosphere. So it's the burning of fossil fuels that are the huge problem. And then how about methane? Do you guys know what methane is?
What cows like.
Not just cows, you too. So anytime food is digested or rotten, it releases methane. So methane is fart, yes. But can you think of anywhere else that food or vegetation kind of sits around and rots? Dumpsters, that's another one. So farts and dumpsters have a similar smell, don't they? A stinky smell. Can you think of some places that are kind of stinky?
Dog food factory.
Okay, oh, well, that's not it, but landfills. But how about something natural that's a little
Greenhouse.
stinky?
Your
bathroom? Nothing human involved.
trees,
How about swamps?
mulch,
Swamps?
mulch.
Ever been to a swampy area in the woods? Doesn't it kind of stink like a fart sometimes? Swamps are similar to landfills with all that water and vegetation and mud. There's a lot of decomposing of living things. So even swamps, or when you defrost the frozen tundra and it turns into a swamp, more methane is released into the atmosphere. So there's lots of different ways that we're releasing methane into the atmosphere, more now than we ever did. And finally, those greenhouse gases, they trap the heat as they try to leave the earth, and it'll cause an increase in the temperature on earth. That's it. You guys have no homework. For the record, my other classes are going to have homework because they didn't do page 16 like you guys did. So if somebody from my other class asks what for homework, don't tell them nothing. They have to do page 16. As always, it is posted on Teams, so.